October 7th, 2025. The world had been waiting for this moment. The European Space Agency was finally releasing the first official images of 3I Atlas, the mysterious interstellar object slicing past Mars. Scientists, space enthusiasts, and journalists across continents prepared for breathtaking detail, the kind of cosmic portrait that would echo through history. But when the images dropped at 9:22 UTC, what the world saw wasn't awe. It was confusion. A single, faint, blurry dot, barely brighter than the noise around it. No tail, no structure, no revelation, just a smudge lost in the black. Within hours, outrage exploded online. On X, Reddit, and every major science forum, the same question burned through the noise. How can a billion-euro mission give us this? Hashtags like fuzzy dot and hashtag where are the pics began trending in multiple languages. ESA's official posts flooded with sarcasm, disbelief, and conspiracy threads. Side-by-side comparisons popped up almost instantly, amateur astronomers posting their own captures from backyard telescopes, some of which appeared sharper, clearer, more real than ESA's release. By noon, ESA's social feeds were chaos. Meme pages mocked the image, while analysts accused the agency of hiding something. And when NASA, China's Tianwen-1, and the UAE's Hope mission all stayed silent, refusing to release their own data or even comment, suspicion only deepened. Had the world's most watched flyby in years been turned into a cover-up? Or was this simply a case of physics refusing to cooperate with human expectations? Even major news outlets struggled to find clarity. Some quoted insiders claiming instrumental limitations. Others hinted that sensitive findings were being withheld for verification. But no one could explain why. In an age where our phones can capture a distant moon in high detail, the most advanced eyes on Mars had produced little more than a glowing speck. And as the confusion spread, so did fascination. On YouTube, breakdown videos surged. Lumora, that's us, began piecing together what others wouldn't say out loud, that maybe, just maybe, what we were seeing wasn't failure, but the edge of what our instruments could even perceive. Because sometimes, what looks like nothing is where the real mystery begins. The story of 3I Atlas wasn't over. In fact, it had only just ignited. The blurry dot was just the spark. Behind it waited a web of silence, numbers, and physics that would test everything we thought we knew about interstellar visitors. While the internet drowned in outrage and memes, the engineers at ESA sat in quiet disbelief, not because they had failed, but because they had expected exactly this. The KISS camera aboard the ExoMars Trace Gas Orbiter was never designed to chase visitors from other stars. Its purpose was humble, almost poetic, to map Martian canyons, dunes, and frost, capturing the planet's slow changes in breathtaking color. When they pointed it toward 3I Atlas over 30 million kilometers away, the rules changed. Each pixel of KISS at that range covered nearly 340 kilometers, enough to swallow entire volcanoes, enough to erase a comet's heart into a single point of light. At that scale, even a perfect lens can't distinguish structure. The light of the comet smears, bleeds, and fades, its entire being compressed into a single flicker on the sensor. Dr. Nick Thomas, the mission's principal investigator, described it bluntly. It's a stretch, even to get a detection. To catch that faint glow, his team had stacked exposures, refined tracking algorithms, and filtered noise until the data could barely hold together. And still, the result was what the world mocked: a fuzzy dot. Not a cover-up, not deceit, just physics drawing its line. The comet's coma, that vast ghostly cloud of gas and dust stretching thousands of kilometers, blended seamlessly into the cosmic background. The nucleus, the solid core everyone wanted to see, was buried deep inside, too faint, too small, too far. As Dr. Thomas explained, at this distance, even the best hardware on Mars could only confirm that it's there, not what it is. But that wasn't enough for the internet. People wanted a face, a tail, a secret revealed. Instead, they got a fingerprint, proof of existence, nothing more. And yet, within that fingerprint lay something extraordinary, a signal pulled from silence. For the scientists, the victory wasn't in clarity, but in detection itself. For everyone else, the victory felt hollow, a billion-euro blur that sparked more questions than answers. So eyes turned to the next hope. HiRISE, NASA's high-resolution camera aboard the Mars Reconnaissance Orbiter. If CASIS could see volcanoes, HiRISE could see rover tracks. At 30 million kilometers, maybe it could capture a few pixels of the comet's core. Maybe it could redeem the story. But just as the world's attention shifted toward NASA's silent machine orbiting Mars, the data feed went dark. October 1st, 2025, a U.S. government shutdown froze every channel, every uplink, every release. HiRISE went offline. No commands, no updates, just silence. And so, the blurry dot wasn't just a technical limit anymore. It was the first chapter in a greater mystery. A silence that stretched far beyond pixels. As ESA struggled to calm the outrage, the world turned its gaze toward the other watchers. The silent giants orbiting Mars. 3 nations, 3 eyes in the sky, NASA's Mars Reconnaissance Orbiter, China's Tianwen-1, and the UAE's HOPE mission. Each had the capability to observe 3I Atlas. Each said, nothing. The HiRISE camera, humanity's sharpest eye around Mars, was supposed to deliver redemption, an image that could cut through the noise and restore trust. Its optics can trace rover wheel tracks from orbit, resolve boulders smaller than a car. At 30 million kilometers, it wouldn't give us portraits, but at least glimpses. A few pixels, a hint of structure. Enough to silence the doubters. But HiRISE never spoke. The U.S. government shutdown, which began on October 1st, had frozen all civilian space operations. Command uplinks halted. Telemetry logs stopped. No data flowed in or out. Even NASA's usually open-access archives went dark. By the time 3I Atlas swept past Mars on October 7th, HiRISE was blind, not by malfunction, but by bureaucracy. And for the public, that technicality didn't matter. It looked like deliberate silence. When amateur astronomers refreshed the HiRISE archive that night, they found only gaps. No planning files, no pending sequences, nothing. Across forums, screenshots of those blank pages spread like wildfire. If NASA wasn't hiding something, why was there nothing at all? Then came the second blow. China's Tianwen-1 and the UAE's HOPE missions, both tracking the comet's approach, also released nothing. No images, no statements, not even denials. 3 major space agencies, 2 continents, 1 object, and total silence. Explanations circulated fast. Some blamed technical limits, others cited political caution. But the coincidences stacked too neatly, and in the internet's collective mind, coincidence quickly became conspiracy. For every hour without data, speculation multiplied. Videos claiming optical suppression, leaked telemetry, and redacted images gathered millions of views. One popular post read simply, "When the sky goes quiet, it's not because there's nothing to see." That silence became the real story. HiRISE, once the crown jewel of Martian imaging, now symbolized a blackout, a missing piece that no one could explain. And while official agencies buried themselves in procedure and protocol, the public turned elsewhere. If NASA wouldn't show the comet, someone else would. Amateur astronomers from Italy to Japan began posting their own captures, stacking dozens of frames, applying AI enhancement, and declaring they had seen what the agencies wouldn't show. The image war had begun, and it would split the internet in 2. Within 48 hours, the world was no longer waiting for official images. It was making its own. Across X, Reddit, and Discord astronomy servers, thousands of amateur astrophotographers uploaded frames of 3I Atlas, each claiming to have pulled more detail than ESA ever dared to show. Some used small backyard telescopes with long exposure stacks. Others fed blurry frames through aggressive AI upscaling tools that promised to restore lost structure. By October 9th, the online universe had split cleanly in 2. One camp insisted the amateurs had done the impossible, capturing a defined nucleus and even faint jets. The other camp warned that the new details were ghosts born from over-processing. The face of the first movement was Maya Trin, a comet hunter from Melbourne whose posts turned viral overnight. She released a sequence of images, each more enhanced than the last, with glowing arrows pointing to what she called non-random streaks around the nucleus. Her followers saw patterns. Her critics saw artifacts. Professional astronomers pushed back with quiet frustration. They ran simulations, stacked their own calibration frames, and demonstrated how simple noise could masquerade as structure. Cosmic rays, hot pixels, sensor drift. When amplified, these random intrusions aligned just enough to fool the eye. AI filters, they argued, only sharpened illusions, not truth. As the arguments escalated, technical language flooded the feeds: sigma clipping, deconvolution, pareidolia. Ordinary viewers, lost in the jargon, clung to whichever side fit their belief. For some, Maya's images were proof of suppression. For others, they were proof of human imagination's hunger for patterns. But even skeptics had to admit, the timing was eerie. 3 space agencies silent, one viral astronomer claiming to see more from her backyard than billion-euro hardware. The perfect storm for a digital myth. Lumora joined the chase, not to pick sides but to trace the data. When we compared the amateur images to the case SIS resolution, 340 kilometers per pixel, the math was merciless. Even the clearest backyard shots couldn't possibly resolve a comet nucleus only a few dozen kilometers wide. The sharp edges, the apparent jets, all mathematical ghosts. And yet those ghosts were powerful. They filled the vacuum left by silence. Because when the institutions stop speaking, belief becomes data. By the end of the week, millions had seen Maya's images. They'd debated, argued, and convinced themselves that something extraordinary was being hidden in plain sight. And through that noise, one faint trace of real evidence quietly emerged. Not from orbiters, not from amateurs, but from the dusty surface of Mars itself. A single streak caught by the Perseverance rover, 1 pixel wide, diagonally slicing across the Martian sky. No one knew what it was, but it changed everything. October 7th, 2025. Jezero Crater, Mars. While the world argued about fuzzy pixels and conspiracies, Mallory Lefevrant, shift lead for NASA's Perseverance rover, faced a simple curiosity. What if they tried to see it from the ground? The rover's navcam wasn't meant for cosmic hunts. It photographed rocks, dunes, and the sky for weather checks. But Mallory authorized a quiet experiment, 10 minutes of continuous exposures toward the coordinates of 3 Salish Atlas as it tore past Mars at nearly 90 kilometers per second. When the frames came back, they showed a single faint diagonal streak, 1 pixel wide, stretching across the image like a scar in the stars. At first, it looked like a sensor glitch or a passing cosmic ray. But when they checked the timing, the streak matched the comet's predicted path to the second. The math was brutal and precise. At 90 km/s, 3 Salish Atlas would cover around 54,000 kilometers in 10 minutes, the same length as the streak. It was motion blur, a faint fingerprint of something real, moving fast, too faint to see clearly, yet undeniable. Still, one mystery refused to fade. If the camera's exposure had been shorter, the object would have had to be much closer, maybe even in Mars orbit, to draw a streak that long. Without the raw Fitz headers, no one could confirm the timing. Was it the comet, or something else entirely? And then, another coincidence surfaced, one too perfect to ignore. Draw a line from Jezero's sky that night, and it passes within degrees of the coordinates of the Wasau-Wow signal, the unexplained 72-second radio burst detected on Earth back in 1977. The same hydrogen line frequency, the same patch of Skikie. Online forums erupted. Calculations filled with power estimates and radio strength comparisons. To replicate the wow signal from 600 astronomical units away, the source would need at least half a gigawatt, maybe 2, if beamed directly toward Earth. That's the output of an entire power plant, focused across the void. Yet not a single observatory, not even those monitoring the flyby, released hydrogen line data. No listening campaign, no spectrum dumps, not even confirmation that they had checked. The silence was no longer optical. It had become radio silence. On October 29th, 3I Atlas slipped behind the sun, hidden in the blinding solar glare. For 40 hours, every telescope went blind, and in that darkness, every theory, from outgassing to alien maneuver, found room to grow. By early November, astronomers prepared new tests, brightness curves, orbital shifts, and radio scans. The JUICE spacecraft would soon observe it again, but data wouldn't reach Earth until 2026. Until then, humanity waited, staring into silence. And maybe that's the lesson 3I Atlas left behind, that in the search for truth, the universe doesn't always answer. Sometimes, it just holds up a mirror and asks how much uncertainty we can bear. Because between noise and signal, between pixel and mystery, is where wonder lives, and that's where Lumora will always look next.